We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello friends, in this session we will discuss about projections of solids, that is prism, pyramid, cylinder and cone. Types of solids are shown over here. These are various regular solid shapes, that is this is hexagonal prism, this is pentagonal prism, triangular prism, hexagonal prism and so on. And these are some day-to-day usage objects of various solids. This is hexagonal pyramid and these are different regular solid shapes that we see in our day-to-day life. Some more solids shapes. Why I am showing all these figures to you? Just to show the importance of classification of solids. All these solids can be classified into 2 main groups. One is polyhedra and another is solids of revolution. Now what is polyhedra? A polyhedra is defined as a solid bounded by planes called faces which meet in straight lines called edges. Of course this definition looks little bit difficult to understand. Now let me explain with this diagram so that you can understand this definition much clearly. Polyhedra is, this is say polyhedra. Why? Because this solid is covered by planes. Say suppose this is hexagonal prism. It is covered by one hexagonal face top side, another hexagonal face is bottom side, and all 6 sides are covered by rectangular faces. So 6 rectangular faces and 2 hexagonal faces covers this solid. So it is one shot of polyhedra. Similarly, this solid is covered by one hexagonal face, that is base, and 6 triangular faces. So this is also polyhedra. Now read this definition. It is a solid bounded by planes called as faces which meet in straight lines, and these straight lines are called as the edges of this solid. Prism, pyramid, tetrahedron, cube, that is hexahedron, octahedron, dodecahedron and icosahedron are the examples of polyhedra. And we have to discuss about only prism and pyramid because in engineering syllabus only 2 solids are widely used. Now what is prism? In polyhedra, further it is divided into 2 categories, prism and pyramid. So prism is a polyhedra having 2 equal and similar faces. Suppose this is a square prism, so upper face is square, lower face is square, and both these squares are joined with a straight lines like this. So it becomes a prism. Suppose this is pentagon, upper face is pentagon, lower face is pentagon, and both these pentagons are joined with the straight lines. That is called as prism. Similarly, this is hexagon. So these straight lines by which these bases are joined, by these regular polygons are joined, that is called as the edges. And this plane, that is called as face of this rectangle or face of this prism. The imaginary line joining the center, that is of upper regular shape and lower regular shape, that is called as the axis of this prism. This is a triangular prism, this is triangular face, this is edge, this corner is edge 1, 2, 3, and this is axis of this solid, and these are the faces. This is rectangular face, this is square prism, this is pentagonal prism, and this is hexagonal prism. Now second, that is pyramid. How to define pyramid? See, pyramid is a solid in which one regular polygon is there as a base and that polygon's all corners are joined with one point with straight lines. That is called as pyramid. And this is the definition. It is defined as a plane surfaces as a base and a number of triangular faces meeting at a point somewhere here. So that point is called as vertex point or apex point. And the imaginary line passing through the vertex point and the center of this polygon, that is called as axis of this pyramid. Second group, that is solids of revolution. When a solid is generated by revolution of a plane figure about a fixed line, that is called as axis, then such solids are named as solids of revolution. For example, cylinder, cone, sphere, ellipsoid, paraboloid and hyperboloid. In our syllabus, we have to study about cylinder and cone only. So cylinder, what is definition of cylinder? A right circular cylinder is a solid generated by revolution of a rectangle about its vertical side, which remains fixed. If we rotate a rectangle about its one side, then it creates a cylinder. Similarly, cone, to create cone, a right circular cone is a solid generated by the revolution of a right angle triangle about its vertical side, which remains fixed. If we rotate a right angle triangle about its vertical side, it forms the cone, and this vertical side is called as the axis of this cone. Now we discussed about how to take projections of various solids, and first case, that is axis perpendicular to horizontal plane and parallel to both the planes, vertical plane and projection plane. This is horizontal plane. This is a square pyramid. It is resting on its square base on horizontal plane. This is vertical plane. So if we look from top, it will look as a square, and if we look from front, it will appear as a triangle. So draw these two views. For that, draw an XY line. This XY line represents the intersection of horizontal plane and vertical plane. And below XY line, draw a square like this, the top view of this solid. And name endpoints A, B, C and D. You can give another name as well. And draw its diagonals AC and BD, because this is a pyramid, and apex point O, which is at the intersection of both the diagonals. From point A and D, draw projection line up to XY line, and at XY line it cuts at 2 points, A dash B dash, and here at C dash and D dash. In front view, if you look from here, this A, B, C and D. So A and B will be over here, right? Suppose this is point A, this is B. So if you look from here, then A and B would be here. So that is represented by A dash B dash. Similarly, C and D are here. If you look from here, then C and D will be at the same point somewhere here. So this is C dash and D dash. Now draw its front view. How to draw? Of course, its height. We should know its height by taking its height over this axis to be drawn from this intersectional point O, and make a triangle. So this is front view of this pyramid, and this is top view of this pyramid. Hope it's clear to you. Now second case, axis perpendicular to VP and parallel to both HP and PP. How to draw projection of this solid? This is horizontal plane, this is vertical plane, and axis of this solid is parallel to horizontal plane and perpendicular to this vertical plane. So to draw projection of this solid, first of all draw XY line that represents intersection of HP and VP, and above XY line draw a hexagon, because if we look from front side somewhere here, then this hexagon will appear above XY line, above HP. So above XY line, dimension whatever is given in the data that you have to take over here. Now draw its axis or center line. Name the points 1, 2, 3, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. Dash should be marked because it is front view. Similarly, A dash to F dash. Height, whatever height is given, take that distance over here below XY line. and draw projection from A dash, B dash, C dash, D dash, E dash, F dash, all points, and mark here A, B. A would be here, B, C, D, E, F, and complete this rectangle. So this hexagon is the front view of this solid, and this is top view of this solid. If you look from top, it will appear like this. If you look from front, it will appear like this. This is the hexagon, and this edge, this and this are fully visible from top side. So these lines are drawn to be visible, and this corner, this one and this one, that will not be visible, so that should be drawn by the dotted line. But here dotted line is overlapped by this full line, and priority is given to the full line. Now case number 3, axis perpendicular to PP and parallel to both HP and VP. Draw XY line, and here side view should be drawn first, because this appears as a triangle in side view. If you look from front, from this direction, it will appear as a rectangle. If you look from top, it will appear as a rectangle. From side view, it will appear as a triangle. This is a triangular prism or pyramid. Yes, it's a pyramid because two triangular faces are there. If one triangular face is there, then it is pyramid, but this is prism. So draw a triangle of given dimension above XY line. Name endpoints ABC, or double dash, A double dash, B double dash, C double dash, and 1, 2, 3 double dash. And then take its length over here. In front view, it will appear like this rectangle having length is equal to L. Mark its center line or axis, and from this base draw horizontal line. From this draw horizontal line, or this is an projection line. So this is the front view. Name the points. This rectangle is front view. If you're looking from here, this will appear like this. Now to draw its top view, take projection from here, vertical line from here, line at an angle of 45 degree, and project it over here. So this is projection of its center line. Then project this point. Similarly, A1 would be here. Similarly, B1 would be here. B and 2 would be here. A1, B2. Now where will be C3? Yes, C dash 3 dash is here. C double dash 3 double dash is here. So project point C is 3 on this top view. So vertical line from point from here, 45 degree line and horizontal line. Yes, so here C and here 3. So if you look from top, C point would be here at the middle between A and B. Here is A, B and C, right? So C3 is this one, and this is the top view of given solid. So this is front view, and this is top view. I hope it's clear to you. Now fourth case, a right regular pentagonal prism, side of base 30 mm and height of axis 75 mm, resting on HP on one of its base corners, such that its long edge containing the corner is inclined to HP at 60 degree. Draw the projections. Data looks somehow typical, but first just consider this one. It's a pentagonal prism, axis 60 mm, 60 degree to HP. So first of all, just draw pentagon like this. And here it is given that its corner is make some angle. So whenever it is given that corner makes some angle, you should draw pentagon like this, such that this side should be perpendicular to XY line. Name endpoints A, B, C, D, E, and 1, 2, 3, 4, 5. Mark its axis point by joining corner with midpoint of opposite side. Corner with midpoint of opposite side, both will intersect at one point. So this is axis, and join this, draw its axis, height 75 mm, that is given. So take projection from endpoints A, B, C, D, E, and mark respective points A1 dash, B1 dash, C1 dash, D1 dash, E1 dash, and so on, and complete this rectangle. So this is front view. Now draw this rectangle in such a way that its angle with HP is 60 degree. Here angle of this axis with horizontal plane is 90 degree, but in data it is given that angle is 60 degree. So redraw this rectangle at an angle of 60 degree. and take projection as we discussed earlier. By taking projection from respective point, A dash vertical line from point A dash, horizontal line from point A1, both will meet at point number A. Similarly, projection line from point B dash, B1 B, then C1 C, D1 D dash and D1 D, E dash and E1 E, 1 2 3 4 5 and so on, and join these points. If we are looking from top, this pentagonal face would be fully visible, so join ABCDE with full line, and this 1 2 3 4 5 with full line, but this line 1 5 and 1 2 will not be visible, so they should be drawn as a dotted, and rest of lines are full, like this. This is 4DC3. This covers this corner, so this line will become invisible. So this line should be drawn dotted. 5 1 and 1 2. Similarly, 1 2A will also not be visible in top view, so that also should be drawn as dotted line. So this is final drawing. Name, this is front view, this is top view. Hope it's clear to you. Insert the dimension, draw its axis. If you don't understand this problem in examination, just draw these two views, pentagonal top view and rectangle. If it is a prism, front view will be rectangle and top view will be appropriate polygon. Just only if you draw this one, you will get at least 50% mark of that problem. If problem is asked for 6 marks, you will get 3 marks. So it's much easier. Thanks for watching. Feel free to contact me for any query.